Guys, so we're continuing with question 16. It says this point minus 3 minus 2 is mapped onto R1 by that transformation. The transformation is represented by this matrix. We're supposed to find the coordinates for R1. And so so we have this point here. This point is mapped onto R1 by this matrix. So we want to find the coordinates for R1. So what it means is we have to get R1 in this form, in the coordinate form. So what you do here is you take your original point, so minus 3 minus 2. This is your original point in matrix form. So it's a raw matrix. So it's a raw matrix. That's what we did. So, and then you multiply by the transformation matrix. You should get the mapping. So you should get R1 here. When you're multiplying matrices, you do row by column. So row by column. So R1 is equal to here. What you do is you say negative 3 multiplied by 1 plus 0. This one will yield 0 because it's negative 2 multiplied by 0. So you get 0 here. And you go on to row again. So negative 3 multiplied by 0 plus negative 2 multiplied by negative 1, like this. So this is the matrix that we get. So here you get negative 3. Negative 3 multiplied by 1, you get negative 3. So, and there you get 0 this part, and this part you get 2. Therefore, this is how we write therefore in maths. R1 equal to, because you want the coordinate, so you just want it in that form. Minus 3, 2. Minus 3, 2. So what changed here? It's only the ordinate, the y ordinate. So if y flip, that means this transformation, it's a reflection in the x-axis. So just a quick note there. So let's move to 16b. So 16b, we have this in the diagram, triangle P. So I didn't actually label this, but I think this was P and this was Q. So triangle P is the image of our triangle Q. Okay, so this is an image of triangle Q under a certain transformation. Describe the transformation fully that maps triangle P onto triangle Q. The first thing that comes to mind is that these triangles, they didn't deform, so they are congruent to each other. They are the same in terms of dimensions, at least. So that narrows things down. How? We can know that it's either rotation. These are congruent transformations. It can be reflection. Or 3, it can be translation. So it can be translation. So rotation simply means, well, you'll be moving a triangle, this shape, you'll be moving it about a certain point. Reflection means you'll be reflecting it about a certain line. Then translation means you'll be just moving it. So here, as you can see, those two, they're facing each other. So when they're facing each other, we have to go with reflection. The other one, it's a reflection of the other one, as if there is a mirror there. So what you do is that you write, it's a reflection, the transformation, right? And then after that, you qualify reflection about what point. So here you have minus 2 up to 1, right? And then what's in between here, you can even count boxes. These are 9 boxes according to what I wrote here. So the box in the middle would be the 4.5 box. So it will be here. Let me just quickly do this. So the 4.5 point, it will be here, and this one would be the line of reflection, this one here. So this one would be the line of reflection. So what's the equation for this line? For lines that go up and down, those lines are x equal to something. So lines going, so you just have to find where the line crosses the x-axis. So here it crosses on the negative 0.5. So reflection, then you say about x equal to negative 0.5. So just a recap, you have to check, as my triangle deformed. If it hasn't deformed, it means that the transformation, it's congruency. So it means it doesn't change the shape or the dimensions of the triangle or whatever shape it is. So you narrow it down to either 3. So it can be reflection, rotation, or translation. Translation means there will be the triangles, they'll be facing the same direction. Reflection, they'll be facing each other, so as if one is a reflection of each other. If you were to put a mirror here, the other one would appear as if it's a reflection of the other one. And then rotation, it means that the triangle we have been rotated about a certain point. Let's move to question 17. Question 17 says it is given that G is proportional to M over R and G is equal to 1 when M is equal to -2, and we saw a given conditions. And the first question says find the formula connecting G, M, and R. So what you do is you first write your relation. So this one says G is proportionate to M by R, and when you remove this, you introduce a constant. So the constant would be K. It'll be Km over R, like this. So whenever you remove the proportionate sign, you introduce a constant. And if they are asking for the formula, it simply means you get the formula in terms of equals, and also get the value for K and then substitute. So we're given that when G is equal to 1, so G is equal to 1, M is equal to 2, and R is equal to 3. So this is a data set. These are the conditions that we use to determine the value of K. So G equal to 1, and K here, M 2, and R here, it's what? It's 3. So we need to get rid of this so that we are left with K alone. So what do we do? If you want to get rid of a fraction, you multiply by the reciprocal. So here you have 2 over 3, you multiply by 3 over 2. So this one cancel, these ones cancel. So you get K equal to 3 over 2. So therefore G is equal to 3 over 2 M over R. So G is equal to 3M over 2R. This one is our formula. This is the formula that they require. And you can see that even when you substitute G equal to, when you substitute, let's say M equal to 2, you get 6 on the upper part. And when you substitute R equal to 3, you get 6 on the lower part. And 6 divided by 6, you get this one. So the sum of these things you can actually verify whilst you're in the exam. So we got G equal to 3M over 2R. So G equal to 3M over 2R. That's what we got. And so now, the second part is substitution. So they want us to find the numerical value for G when M is equal to 10. So this is a simple substitution. And when R equal to 3. So here you start cancelling your stuff. So these ones they cancel, these ones they cancel, and then you get 5. So here, done. So question 17, it was relatively easy. Let's move to question 18. So question 18 says we have A, B, C, D on the circumference, points on the circumference, and PD, this one is a tangent. to the circle at point D. So this is point D and this is a tangent, and we are asked to we are given these two. So we're given these two and we're asked to find BAD. So BAD, we're asked to find this angle here. We don't know that angle. How would we go about finding it? So here you see this one. It's whenever you're given a problem in geometry, always find some of those obvious angles, some of these obvious tips. So you have this one, it's a diameter. Every angle formed on the circumference from the diameter, it's equal to 90 degrees. So this one should be 90. This one is a diameter and it's forming an angle here, so this one should be 90. And also angles subtended from the same chord. So for example, this one, it's a chord you identified, it's subtending two angles here. So on the circumference, there are angles subtended, they are equal. So here you have 47, this one must be 47 as well. So it's just some of those you know, easy angles, and you can just declutter your work by writing those angles in advance. So here also we have this one, it's a chord and it's subtending two angles, this one and this one. So this one should also be 28. So you can actually fill this up before you but then it's not advisable, of course. That's just those obvious angles and you're done. And BAD, so BAD, this whole angle here, this is what we need to find out. So we have angle BDA, this angle here, BDA, this angle, plus angle BAD plus 90 degrees here. It's equal to what? It's equal to 180 degrees. So here BDA plus BAD is equal to 90. Why? Because 180 minus 90, you get 90. And BAD, we are finding BAD, but we know BDA. BDA, it's 28. So BDA, it's 28 degrees plus BAD, which is equal to 90. Then BAD is equal to 90 minus 28 degrees. So 90 minus 28, you get 62. So this one should be 62 degrees. And CDP, CDP, so this angle here, that's the angle that we're looking for. Whenever you see a triangle, this triangle, it's resting, it's forming this angle at the tangent, this triangle DAC. The base of this triangle, it's resting on this to form this angle with the tangent. So always this one should be equal to the, if you go inside this triangle and you go to the opposite, they should be equal. So this angle and this angle, according to theorem, they should be equal. So angle subtended at the tangent, it's equal to the opposite interior angle, you know, for the triangle. So here it should also be 47 degrees. So this one should also be 47 degrees. Then CAB, so this angle, that's what we are finding. And this angle, it's here you know that for this whole angle BAD, we found it is 62. So we just say 62 degrees minus this angle, which is 47 degrees. So you can even do it here, 62 minus 47. Here you get 12 minus, you get 5. Then here you so it's 15. So 15 degrees here. And the last part says BCD. So B here, C, D. So BCD, this angle is the angle that we want. So this whole angle here. And we use this theorem, CABCD. This is a quadrilateral. So here, this angle, it's opposite this whole angle here. This whole angle here, we had determined that this whole angle here is what? 60, it's 62. So we say 180 minus 62. Because opposite angle in a cyclic quadrilateral, they add up to to 180. So 180 minus 62, 62, which is the opposite angle here, DAB. So 180 minus 62, what do you get? 118 degrees. So yeah, so you get 118 here, and you're done. Let's move to question 19. So what does question 19 say? Oh yeah, this one is easy. We just have to expand. So you have 4b minus 3 open bracket 4 minus 2b. So here you expand by here you have to clear the brackets, but then you have to understand that this one multiplies everything that's inside. So you go in steps. Negative 3 multiplied by 4, you get negative 12. Negative 3 multiplied by negative 2b, you get what? 6b. So 4b plus 6b, you get 10b minus 12. So like this. Then you're done. Remember, negative and negative give positive. That's where the trick is. If you fail to recognize that, if you fail to pick up on that, then you would get this wrong. So yeah, that's it for number 19a. Number 19b says factorize completely. You have x minus y minus xy plus x squared. So this one, it's a very common problem in ZIMSEC exams. And whenever you have 4 entities, usually they want you to match the brackets. So yeah, I can even put these ones, because these ones I cannot because they're just sort of, we cannot factorize them further. So put them here. But then this one, it's a your model bracket as well. This one, you want to create another bracket by factorizing this. That's exactly this. So how do you do it? So you do it by factorizing here. If you factorize x, you get negative y plus x. So x into x squared, you get x. These brackets, they are the same. You just have to rearrange to pick up on that. So plus x, x minus y. So minus y plus x is the same as x minus y. So this one, you could say that there is 1 here. So you can combine these coefficients into 1. So here you have 1, then plus x here. And you have x minus y. So the common bracket, you take it, then you form another bracket from the what? From the coefficients. And then you're done, of course. Yeah, so the idea here is to match the brackets. You should be strategic about it. Sometimes you have to, factor out negative something here. If you factor out negative something for this case, then, you won't get anywhere. Your brackets won't match. They'll have a negative factor there that you still have to scrub up. So that's something to consider. Let's quickly move to question 20. So question 20 says, name the regular polygon which has rotational symmetry order 5. So here it's a pentagon. Whenever you're asked the rotational symmetry of any regular polygon, don't even think about it. The rotational symmetry equals the number of the sides. So for a triangle, equilateral triangle, the rotational symmetry is order 3. For a quadrilateral, the rotational symmetry is order 4. For a pentagon, the rotational symmetry is order 5. So yeah, that's it. For regular shapes, what you have to know is, yeah, even for a pentagon, it's 5. For a heptagon, it's 7. Decagon, it's 10. So this one was a dead giveaway sort of. So let's just move to the second part. I think I will need more space here, so you just scrap that off. And the sum of the interior angles of a hexagon, that's a buzzword. So hexagon means 6 sides, already you know. So is 720 the interior angles. 3 of its interior angles are this, and this, and the remaining angles are in the ratio this, and this. Remaining angles can be, let's say, 6 degrees. If this one is 6 degrees, this one should be 9 degrees, so that they maintain the ratio. And this one should be 15 degrees. What I did was that there was a multiplier that I used here. Multiplier what? Multiplier of 3. That's what I used. So I multiplied everything by 3. So for our case, we don't know what we are going to multiply by. So what you do is that you say let the angles be 2x. The multiplier is 2x, 3x, 5x. So like this. So if you have this angle, if you had these, you just treat them as if they were actual angles, because they are in some way. So if you add them, if you add all the angles, okay, I'm just going to remove the, yeah, so 140, 120, and 160 here. If you add them, you're supposed to get the total, which is 720. And here you get 10x. So 2x plus 3x is 5x, 5x plus 5x is 10x. And here you can add 140 with 1 to 160, then you get 300. And then you say 300 plus 120, you get 420, I think. And here it's 720. So here you have 10x equal to 720 minus 420. You have 10x equal to, this is 7 minus 4, you get 3, so this is 300. You divide both sides by 10, then you get 30. So you can write 30 degrees, it's still okay, something like that. But then that's not really your answer. So if you want, you can even not underline that, because it says calculate the size of the largest angle, of the largest of the remaining angles. So therefore the largest of the remaining angles is, so here we had defined it as what? 5x. So let's just substitute 5x, which equal 5 by 30 degrees, which equal to 150 degrees here. So this is your final answer, this one.